Hello, my dear students. Welcome back to the course Computer and Machine Drawing. Here we are going to discuss about the case study on crane hook. Here is the crane hook. You might have seen in many uh, occasions, like where the heavy loads can be lifted. Here you can see that the crane is used with a hook in an industry. Let us discuss about what is a crane hook. A crane is a machine which can use it to lift the loads, and the hook is the particular device, or it is a component which can be used to lift the load and grab the load, which is used in a crane or a hoist. Here you can see the definition is a lifting hook is a device for grabbing and lifting loads by means of where it is used, by means of your hoist or a crane. Likewise, the lifting hook is usually equipped with a safety latch to prevent the disengagement of the lifting wire, rope sling, chain, or a rope to which the load is attached. Here the ropes will be connected. You can see in the next slide. Yes, this is the hook. This blackish material is the hook. It is connected with the bearing and the rod and the assembly to this pulleys. This assembly is connected with this pulleys. These pulleys will have ropes where the rope is used to lift the hook towards upwards and downwards, where the load can easily transported actually. The crane hook. This crane hook is usually made by forging. In manufacturing process, you might have read about the manufacturing processes like turning, drilling, and casting, like that. This particular crane hook is usually made by forging. This hook, look at here, this hook, the entire blackish material, which I previously mentioned in the previous slides, entire material is made of a single piece of high quality steel. The material is made up of is high quality steel. This high quality steel does not contains the which is a very low carbon. Okay, this blackish material will contains very low carbon, and during the process it is cooled very slowly after pouring of metal. With the metal contains a high quality steel with low carbon, thus molten metal is cooled very slowly. Why it is slowly cooled means this optimum stress resistance. To ensure this optimum stress resistance, usually the ranges will be 16 mm to 36 mm. So this is the part, this is the assembled view, and this is the exploded view of this assembly. You can see the hook. This material is made up of single piece, and these are all the assembly of parts, various parts. Yes, this is the specifications, or whatever you say, the assembly which contains a lot of parts. Locking cap, thrust bearing, where the bearing is used to rotate this hook through 360-degree. The nameplate, hook nut which is used to engage it, Trononion. This hook safety latch is used to uh, not to allow the material which is hanged here, which is not allowed to move away by hook safety latch. This is the load hook where the load is locked in here, and this is the hook saddle where the material completely hanged here. This surface will have the highest stresses. Yes, this is the two-dimensional view where you can see the dimensions, and here you can see the dimensions is horizontal and vertical, and circular dimensions are mentioned here, and you have to carefully note this particular area. Okay, this particular area, I will erase this line, and I will make it as a highlighter. You can see the dimensionings is mentioned with, yes, radius. You can see the number of radius dimensions. So everything you have to give a very careful understanding of dimensions. You can see the distance between this radius here. Look, here you have to understand how should how you should draw this particular hook uh, design, where you can understand the distance between the center line. This center point is distance here, and you have to understand the distance from here to here is around 92, and you have to give 11 from here to here. So this particular hook design is very carefully designed, and students like you have to give more importance to understand the drawing before you proceed to draw it. Look at this cross section uh, of oval shape, and here you can see from this point you have drawn radius 30, and again you're changing this radius center point from here to here is 35, but this distance to this distance you can see here is 5 millimeter, isn't it? And also here you can see the radius is 16, here the radius is r3, and here the radius is r19, and here it is r30. So each and every radius is changing from one place another place. So you have to give a very careful understanding before drawing this particular crane hook. Look at the distance between this point to this point is 33 millimeter. Yes, okay. So after drawing this particular hook, you have to undergo the analysis part, where this analysis part will always use to find the maximum stress carrying by the hook and the maximum deformation, and is there any thermal stresses applicable or not. These analysis will give you the uh, very careful points about the stress distribution in the hook material. Look at this red area. This red area gives the maximum stress. Here you can see the 135. Likewise, here you can see this area, the values are here. So analyzing of this crane hook is used through the ANSYS software, and here you can find the uh, maximum stress here 260 millimeter. Here the reddish area will denote this the value of here, and Here, this reddish area will give the maximum value of here, and these values will always use it to find the performance of this crane hook. This von Mises stresses. Here you can see the von Mises stresses. This von Mises stresses will always use it to find the how long this particular crane hook will work, and how long we can use this crane hook where the application implies. Okay, this is the minimum values, and here is this. It is zero. It doesn't matter, but you have to check then and there while analyzing. Okay, I hope you have understood about the case study of this crane hook. Crane hook is always used to transport material from one place to another place. Yeah, even though we are regularly watching and in regular life, we are watching this crane hook there and there, but we doesn't know about how it is designed and how it is analyzed. So I hope you have understood and enjoyed this session. Take care. Bye.